good question and a long answer. I think traditional APIs and exchanges of information is typically someone makes a request and then someone responds or replies to that request. So that is very much how HTTP and REST is built. Someone makes a client makes a call to a server responds with information to that client calling the server. In an event-driven world or in an event broker world, it's typically not a request and reply type of structure. Instead, you establish a connection, typically maybe between a client and an event broker, and then you have a persistent stream of data going back and forth. And you typically decouple between entities. So in the REST world and traditional kind of messaging world, you'd have a direct interaction between a client and a server. But in the event world, you typically talk about publishers and subscribers. And you have this concept of maybe one entity is publishing a message to an event broker, and then you might have 5 other entities subscribing to the same message. So you have this kind of multi-subscription, multi-publishing type of thing. So that's fundamentally a big difference. And then the technologies around it, of course, might be different as well. You might be talking about an open API specification to describe traditional RESTful APIs, and then you might talk about Async API, for example, to describe the event APIs. I think one of the challenges is that a lot of tools out there in the market today is obviously created to, on top of standards like REST and HTTP. In the event world, there's so many different technologies and so many different flavors of queues and streams and other types of technologies. And traditionally, there's been kind of a lack of standardization as well as of a lack of developer tools to work with these technologies. So if you're coming from a REST world, for example, you might be accustomed to the concept of a developer portal where you can discover APIs, you can maybe try them out, test them, see the documentation, very easily integrate them in your applications. But when you talk about event-driven architecture, it's historically mainly focused on the backbone of an enterprise architecture, and the tooling to work with developers with those technologies are not always as mature as technologies for traditional APIs. Another challenge is that a lot of applications are not necessarily able to talk these event protocols or event message and communication structures that you need in an event-driven architecture. So a challenge with implementing event-driven architecture is that you sometimes have to consider those applications and consumers or producers of data that are not themselves born in an event kind of native world, if that makes sense. One of the obviously main values of having an event-driven architecture is that you can get business value from something happening in the organization much quicker. You can take a real-time decision, and maybe that decision that you take in real time is going to give you much more value, or the customer would get much more value versus having to take a decision in a traditional non-real-time world. Well, I think what is important when implementing event-driven architectures, and we obviously have some customers that have done this very well, is that on top of implementing a strong backbone and messaging and queuing mechanism where you might have different connected devices streaming data in an event mesh, for example, across multiple data centers and across multiple physical devices and software applications. Typically, organizations that implement event-driven architecture well, on top of that, builds a good developer experience, primarily for internal developers, but maybe also for partners and other consumers, where you build up tooling and capabilities to allow those event architectures to live alongside your other type of applications and communication messages, like traditional REST APIs, for example, to provide this kind of unified developer experience and unified way for your architects and your API or event managers to be able to produce APIs, whether it's asynchronous and event-driven APIs or traditional APIs, in a kind of consistent manner with great flexibility in terms of where it makes sense to have a real-time use case and where it makes sense to have a traditional synchronous type of use case. It is quite rare for companies to implement a hybrid solution for both event-driven architecture and traditional APIs, for example, REST APIs. Either it might sit in different technical teams or business teams in the organization, or from a tooling perspective, it's just not possible to have a unified approach for how you produce your APIs and services and how people can consume them. So I think when we see people doing that successfully, they typically have a strategy around aligning the teams and putting governance on top of whether you're creating and exposing an event-driven API or a traditional, maybe a REST API. This is how you do it. This is the process you go through. This is what the schema should look like. This is what the documentation should look like. This is what the security should look like. And that you have also a consistency to your developers. This is how you're supposed to access and subscribe and get analytics and alerting for your APIs, regardless of how that underlying technology is providing the data. One thing that we need to be clear on is that messaging and event-driven architectures are not necessarily something new that are just being introduced kind of the last 2 years. It's been something that's been around for a while, but the increase of data and the increase of customer experiences and consumer experiences wanting to be real time and for organizations to get more value by taking decisions much quicker has accelerated, along with the IoT kind of motion, have accelerated the need to deliver this type of real-time and asynchronous services. The challenges that API management has traditionally is that API management was kind of coming from a SOAP and HTTP type of background to manage APIs that are working in a synchronous way with request and response type of architectures, and built around tooling like the OpenAPI specification, for example, and indeed the REST protocol to allow consumption, discovery, and traffic shaping for APIs. So that is a challenge that exists today in a tooling perspective, that if you want to achieve the same type of analytics, logging, security, transformations, it is a bit difficult to apply that for your event APIs. One of the reasons for this is fundamentally from an architecture perspective. When you make a big enterprise platform like an API management platform often is, you obviously drill down into the core functionality of your data plane, typically known as the gateway in an API management space. And you might build that on different types of technologies to kind of leverage from different proxying technologies, for example, to work on a request response type of pattern. And not always is it very easy to break that dependency on another type of underpinning technology for a gateway, potentially to have the ability, for example, for your gateway to be able to listen for events in a Kafka topic or an MQTT queue, for example. So it's a fundamental architectural and technical difference, typically managing and allowing people to discover and interact with asynchronous APIs. And that is historically, I think, why the API management space is struggling a bit to adjust their technologies, both on the control plane, where you manage your documentation, your analytics, your access, and on the data plane, where you manage things like talking to other types of protocols, understanding other types of protocols, and having the ability to decide whether you want to expose your event-driven systems through a traditional REST API or through maybe a webhook or WebSocket technology to still keep it asynchronously, but maybe on the HTTP protocol. The challenge that you typically have as an API management vendor is that a lot of your investment, a lot of your engineering and architectural work is in the finer details of how your gateway operates. You want to have very good performance, of course, in terms of latency. You want to make sure it's a very robust gateway component that you provide in customers' installations, because it's obviously a very key piece of infrastructure that should work and should be very performant and reliable. Now, as you are looking to reshape that very core architecture to make it event-driven kind of native, if you will, it is a big piece of work typically, and you might be limited based on the technologies that you've decided to build your API management platform on. Event native means that you are able to deliver to customers an event-driven architecture support for APIs through the entire lifecycle of APIs. So what I mean by that is that from a developer experience, when you're discovering APIs in a developer portal, you have support for both Open API and Async APIs. When you design APIs with a design or contract first type of approach, you have the ability to do that for your Open API or your REST APIs and your asynchronous APIs. When you manage security, when you manage view analytics and logging, that is capabilities that you should be able to have both for your traditional APIs and your asynchronous APIs. And of course, all the way to the gateway, which is obviously, again, the fundamental architecture piece that allows to protect your upstream services. That gateway do not only have the ability to proxy incoming requests to upstream backend services through a REST or SOAP or GraphQL type of interface, but also for that gateway to be able to understand and react on and with event-driven architectures and message brokers like Solace, Kafka, MQTT, AMQP, and so forth. So for me, that is event native, the ability and delivery of something that gives developers and API producers an end-to-end lifecycle management of both synchronous and asynchronous event APIs. I think one is obviously future-proofing. So we know that today, a lot of the use cases in production for customers are with traditional synchronous communication methods. But increasingly, what we are seeing due to different trends in the market, and again, better consumer and customer experience and importance of taking real-time decisions and having real-time data, is obviously a move towards event-driven architectures on the architectural side. Now, the benefits of having a solution that is event native and are ready for protecting and allowing discovery and so forth for both traditional and asynchronous APIs is that you know that your API producers, your architects, when they expose APIs within or outside of your organization, they have complete flexibility in how they want to expose them. And that flexibility can be required because of security. Maybe if you have maybe a Kafka event broker, you don't want to expose that outside of your organization just for your partner to get real-time information, maybe. Or maybe you have clients, whether inside or outside, that cannot talk over TCP or over an event kind of streaming protocol, but are comfortable with HTTP. But the data access that they effectively wants to get to might be from an event-driven architecture. So this flexibility is going to be and is starting to be extremely important for organizations when they get requirements from the business side to deliver different types of services to their customers and creating products that they maybe monetize to their partners or customers. So that flexibility to be able to decide how I expose my data is very, very, very key. And that's where event-native API management really helps to kind of future-proof how you're in control of exposing your data. At Gravitee, we've spent a lot of time and thoughts on how we engineer our gateway to make it performant, but also to make it future-proof. So the way we built our gateway is not necessarily on top of an existing service like Nginx or a traffic or other type of underpinning technologies. We're using Java on our core gateway system, which means that it's very easy to extend it. There's a lot of libraries for us to use with whether it's Kafka or MQTT or other type of services that our gateway wants to talk to. But fundamentally, what we have done is we've implemented reactive programming, meaning that our gateway has the ability not only to accept incoming requests and proxy that to various upstream services, but indeed also to listen to events happening in the enterprise, whether a Kafka message on a topic or a a message happening in a queue in MQTT, for our gateway to react to that happening, maybe applying filtering, whatever it might be, and then potentially sending out that message out, maybe over a webhook connection to someone that has subscribed their interest in receiving information about that data. So that is, from a Gravitee perspective, something that we're quite proud of. We've invested a lot in owning that technology stack, basically, which now gives us that flexibility to program it in a way so that it's async API native in addition to open API native, if you will. To Kong specifically, obviously, they have based their gateway on something called OpenResty and Lua, which if you say that the Java is a legacy, then I'm not sure what that is. But I think obviously Java has its pros and cons, right? The cons of Java is that it does obviously require a Java virtual machine to run it. The pro is that it's still kind of the most used programming language to date. So it's very easy to extend, it's very easy to troubleshoot, and it's something that a lot of organizations are kind of comfortable with. So indeed, there's other technologies on the market today that are built on other technologies where you might have potentially a lesser footprint in some situations, but the drawback, of course, is that it's more difficult to extend, and you might kind of struggle with finding kind of libraries and support around those underpinning technologies. At Gravitee, in the mid to kind of short term, is obviously the introduction and rollout of our event native API management platform. So at the moment, we have a lot of interesting stuff that people are able to do today, whether it's exposing your Kafka or Solace topics or brokers, using webhooks, server-sent events, REST APIs, etc. We already have support for Async API in the developer portal, for instance. What I'm super excited about is us really reshaping our architecture and product to be event native. So debugging your asynchronous APIs, designing your asynchronous APIs in a beautiful user interface, having the ability to apply policies and message filtering and traffic shaping on your events as well to your APIs. The ability to provide alerts, so alerting maybe on security breaches or potentially SLAs that you might have, not only for your traditional APIs, but for your event-driven APIs. There's so many capabilities that you expect from a traditional API management platform, whether it's monetization, analytics, debugging, and so forth, that doesn't exist today for event-driven architectures. And that is obviously a big undertaking to go and implement, but something that we are very proud of being on a good journey for delivering. In the next 10 years, you'd probably see a convergence of events and APIs. So you won't necessarily maybe have different specifications and definitions that are unique for asynchronous APIs and traditional APIs. I would definitely see potential merges in the specification and kind of external tooling space. I also see teams in enterprises becoming less siloed when it comes to the actual technologies that they're working on. So whether you're working with an event broker or an API gateway, potentially, you might work in the same team because you're there to deliver business value regardless of what the underlying architecture might underpin that product or that service that you create. So that is something that I kind of see converging. What I also see is this trend that we're currently on in terms of adopting event-driven architectures. And again, the need increasingly of having tooling to expose, document, and control and secure your services, regardless of it being REST, GraphQL, SOAP, gRPC, or any event-driven kind of message broker like Kafka and so forth. So that's kind of where I see the future going from a API management perspective. API management vendors being able to allow producers and owners of APIs to control their services, regardless of what the underlying kind of technology underpinning their upstream services is.